Good afternoon, sir. Professor Bhaskar Rao, sir.
Hello, Dr. Ramesh. Good afternoon.
Thank you, sir.
Good afternoon. Good afternoon, Professor Bhaskar Rao.
Hello, good afternoon, Dr. Srinivasan. Very nice. Thank you very much for the invitation to join.
Namaskar, Master.
Yeah, we want you.
Namaste, Maskaru, sir. Namaste.
Namaskar, Bonara.
Bhavana, sir. Meer Maskar, Bhavana, Gana.
Bona.
So, David, good morning.
Yeah, good afternoon, Dr. Mukhopadhyay.
Yeah, Mukho, good afternoon. Good afternoon.
So, David, we would like to, when we are waiting for other participants, we would like to introduce you to two of our earlier professors. One is Professor Bhaskar Rao. He has been teaching WRF and NWP in Indian universities for a long time and also abroad. And also we have Professor Rao from Brazil, who is also a veteran in the academics of NWP. So he is joining us from Brazil. And we have, of course, Partha, our speaker today. He is from IITM. And David Rogers is he's working with the World Bank, and earlier he was with WMO, and we have a long association, and he was instrumental in RIME's World Bank agreement, collaboration agreement. So he's been this South Asia Hydromet Forum is basically a lot of his groundwork, which has come to this stage now. So glad to have all of you here. Thank you.
Good afternoon and good morning.
Yeah. David, both Dr. Brahmanand Rao from Brazil and Dr. Bhaskar Rao, they are very celebrated academicians. They have produced at least more than 20 PhDs and maybe hundreds of MTech projects under them. And Professor Brahmanand Rao was working in Brazil, just retired a few years before with CP Tech and academic department. And several of his students are in very senior positions in CP Tech and world over, even Nova also. Professor Bhaskar Rao was in George Washington University after his superannuation in Andhra Pradesh. We have oldest academic department, started in British India in 1945, before our independence. So in the east coast of India, we have a department for meteorology and oceanography. So Professor Bhaskar Rao started there for so many years.
Wow.
And I have also graduated from that department. And Professor Bhaskar Rao and Professor Brahmanand Rao, both of them have initially graduated from there. And if you recall, Professor T.N. Krishnamurthy was the student of that department. Later on, he went to US and did wonderful work at Florida State.
Good to know. Very pleased to meet you all.
Srini.
Yes.
Hello.
Yes.
Can you tell Dr. Anshul? I have shared the PPT to him. So I think it is better if he can.
Yeah. Okay. We will do that, Partha.
from here sometime it is, I don't know what is happening.
Sorry, Dr. Partha, but I have not received the PPT. Can you confirm which email ID you sent, sir?
Yeah, just 1 minute. Just 1 minute. Huh?
Sure.
I think Kunpyu, you can probably get a check from Hitesh and start, because I see a lot of participants have joined.
Yes, sir. I think I will begin from now.
Sir, I'll call you after half an hour. I am in a meeting now.
So I think we can begin from now. So good morning and good afternoon, my dearest participants. I am Pirsi Nisharot, an Associate Program Officer from RIMES, and I will be the moderator for you today. So on behalf of the team, I would like to welcome you all to the first of webinar series over the topic of future directors of the operational NWP in South Asia. And before we begin, I would like to hand over the stage to Dr. Srini to give us the opening remarks. And please welcome Dr. Srini. Thank you. Over to you, sir.
Thank you, Kunpyu, and good afternoon and good morning to all the colleagues and participants in this meeting. So welcome to this webinar on behalf of Director RIMES. I am pleased to welcome you all. This is the first in the series of webinars which we are planning as a run-up to the South Asia Hydromet Forum annual session, which is planned in September 2021. So if you recall, I think most of you are familiar with South Asia Hydromet Forum. So this is an initiative from the World Bank, GFDRR, and also WMO's collaboration. We had the first annual meeting where countries in South Asia, mostly the National Meteorological and Hydrological Services, got together to form this forum. And we had the first meeting in Geneva in 2018, and we had a follow-up meeting after that in 2019 in Nepal, Kathmandu. So from there, we were able to come together for a clear initiative. And after that, we were able to formulate this project, and with the support of World Bank and WMO, we initiated this project. And within that, we have started our work through the within the directions of the Executive Council of the South Asia Hydromet Forum, which is comprised of all the directors and director generals of the National Meteorological Services of South Asia countries. So within that, the first priority is on operational services and service delivery. And this is something which we are taking up as a first step within this initiative of the umbrella of South Asia Hydromet Forum. And within that, we have, I think, amongst us, all the working group members for this initiative. There are 4 working groups. There is one on numerical weather prediction. The second one is on impact-based forecasting. And the third is on observational networks. And the fourth is a cross-cutting theme on capacity development and enhancement within the NMHS, which is overarching for all the working groups. So with this setup, we would like to see how regional cooperation can be furthered within the umbrella of the South Asia Hydromet Forum. So the working group activities are very important, and to initiate that, we thought we will have this webinar series which align with the themes of the priorities which are set up for the next 2 years within the South Asia Hydromet Forum. So with that, I think the first talk is from an eminent speaker, who we have requested to give us some idea about how NWP in the region, particularly for operational purposes, which is most relevant for the National Meteorological Services, can be developed, and what ways we should think of developing it as a region in future. So with that, I again welcome you all, and also some of the participants are from countries we are celebrating festival season. So Eid greetings and all the best wishes to stay healthy to all of you. With that, I hand it over back to Kun Phu for introducing the speaker today. Thank you.
So thank you very much, sir. Thank you for the introduction of the program and also the webinar series. And next, I would like to lead you to our next session. And please allow me to share the stage to our honorable speaker, Dr. Partha Mukhopadhyay. He's from India Institute of Tropical Meteorology, Pune, India. He's he's with us today with his expertise of high resolution GZM, and mesoscale modeling of monsoon, heavy precipitation events, and thunderstorms. So please together welcome Dr. Partha to the stage. Over to you, sir.
Yeah, thank you. Thank you so much for all the kind introduction. And I will go straight to my presentation. So, Dr. Ansul, have you received, or should I share it? Okay, yeah. Okay, thank you. Can you go make it full screen? Yeah, thank you so much. Okay. So, as suggested, this title, so I will talk about the future direction for operational NWP in South Asia. But before that, what I will do is that what we are doing presently in handling this regional, multi-hazard system, how we are doing in operational meteorological service here. So I will talk about that, and then at the end I will briefly tell that how it can be extended to the South Asian region, and what should be the most possible road ahead for the NWP over this region. So can you go to the next slide? Yeah, so this is a brief outline. I will briefly say what this NWP system we have used so far, and because I am from IITM, so I will mostly talk about the GEFS modeling system, but there is another modeling system of similar type, at least of similar resolutions, from NCMWF. That I will not elaborate here. And I will also briefly tell about what are the products that we are presently, India Meteorological Department is using in day-to-day basis. And briefly talk about the fidelity of the GEFS for different synoptic weather systems like tropical cyclone, and thunderstorm, heat wave, extreme rainfall, etc. And then future roadmap for NWP from Indian perspective, but can be extended to South Asian. I will summarize. Okay, can I go to, yeah. So this I think is known to this audience very well, that the basic philosophy behind having an ensemble system is that we really do not know where this, a deterministic or single model realization, where it will take us. We really do not know because of basically two uncertainty. One uncertainty arises from the initial conditions, which is an essential component of NWP system, and another one is the uncertainty that is arising from the physical processes. We cannot do much on dynamical code. Okay, dynamical code, either it is a Eulerian system, or it is a semi-Lagrangian system, or it is a finite volume system, and so on. Mostly errors are contributed by these two. One is initial condition, another is the physical process uncertainty. Now, to handle this initial condition uncertainty, we basically use what is known as perturbed initial conditions. Okay, perturbation can be done in several ways. Presently, what we do here is that ensemble Kalman filter based perturbations, and So here is schematic, which shows that this red line is the deterministic one, or we can say the control one, okay, one member, and it takes you to some, space of, projection and predicted environment. But slightly perturbed initial condition, same model can take me to a different, realization. This goes back to Ed Lawrence' famous theory of, chaos and all these things. So the best possible way to handle this uncertainty, initial condition uncertainty, is to have an ensemble. So ensemble is the way ahead. I mean, we cannot depend, however perfect is my model maybe, we cannot depend on single model realization. So we have to depend on ensemble. So I will speak elaborately in this seminar on ensemble model. Okay, so can we go to the next? Yeah, so this is a very brief outline of what IMD in India we have so far done. So there are basically, as you see on the top, we have written seasonal forecasting system. This generates a forecast of, now it generates a 10 months forecast from every month. For example, it runs from July, and then it produces next 10 months forecast. Okay, then it is again run on August, and then again it is generate 10 months. So it goes all the year round. There are 44 members. Okay, now initially when this seasonal forecasting was started, they choose different initial dates as the, as a way to pattern. But now they are also using the ensemble Kalman filter based initial condition to be, for using it as a pattern basis. The model resolution is 38 kilometers, which is fairly, high for the perspective of seasonal forecasting. There is also a system from NCMWF now, which is used for seasonal forecasting. Then comes, so this goes for a season. It gives a forecast for 4 months. So in the month of May, we get a rainfall distribution for June, July, August, September, and so on. In the month of June, we get a forecast for July, August, September. Then there is another very famous window, which everybody knows, which is called S2S, subseasonal variability, intraseasonal variability, which is very, very dominant. All the countries in the Southeast Asia, somewhere or other, experience this subseasonal variability. So for this, to address this subseasonal variability, again, we have two systems in India. One is GFS, CFS based system, and that's what I have written here. So there are basically 4 models, 4 versions of the same model. 2 are CFS V2 T126, which is resolution around 100 kilometers, and then this is T382, it is 38 kilometers. Then these 2 models, GFS, okay, which is the atmospheric version. These are all coupled versions, CFS. These are the atmospheric version. So in these 2 atmospheric model, what is done is the CFS sea surface temperature being bias corrected, okay, is given to the GFS, and then the model is run for 4 weeks, okay, and weekly forecast is generated. Okay, week 1, week 2, week 3, week 4. Earlier it was sprinted, but now IMD has made it week. So 4 weeks. So every Thursday for the next 4 weeks, the forecast is generated, and this is very, very crucial for the farming and agricultural sector. It is found very, very successful in India, and now NCWF also has started another system, extended range. It is for also for 4 weeks, but the resolution is slightly different. It is 60 kilometers. But I will not touch upon on these 2 forecasts. So my domain is this. It is weather forecast. Now in a weather forecast, you may be knowing India started way back in 1980s when the resolution was something around T82, and then it was upgraded to T254, and then subsequently to T574. T574 means it is something around 27 kilometers. Okay, and then it was used as a 27-kilometer deterministic model for a long period of time. Mainly, this constraint was because of a very high-powered, computing system. In 2017, when Dr. Ramesh was there as a DG, and we got this T574 ensemble system. Okay, when we started running a 21 member, so 1 control and 20 perturb member, T574, and we started developing a probabilistic forecast, which is the final goal of running an ensemble system. But then what happened? This 27 kilometer is not a, the resolution is not sufficient to resolve this heavy rainfall event, or, for example, the orographic events and so on. So there was a the demand that this resolution needs to be improved. So then finally, there was an upgradation of HPC in IITM as well as in NCMWF. From 1st June 2018, we could operationalize the TEFS T1534, which is roughly around 12.5 kilometer over the tropics, and ensemble with the 21 members. So this is presently the highest resolution ensemble run in the globe, because ECMWF IFS being run at 16 kilometers. Okay, so can we go to the next? Yeah, so this is a very brief, flow chart of how GFS model is being done. That is the deterministic one, and this is the initially the hybrid data assimilation, where all these perturbations, part of the ICs are created, and then the model, which is a semi-Lagrangian dynamical code, is being run for 243 hours. Why 243 hours? Because IMD has a practice of observing the rainfall from 03 UTC to 03 UTC. Okay, so we run 3 hours extra, so 243 hours with 64 level, and then all these resolution model can generate, but we finally use 0.125 to 0.125. And you can see here I have written it is presently being done in Cray, and with 23 nodes, a single model takes around 90 minutes to complete. Can we go to the next? Yeah, and this is the full system of the ensemble, where you can see the additional 20 part of members are being added here. And if there is a tropical storm in the initial condition, that needs to be, the initial condition takes into account, relocates the vortex, and it again this 21 member. So this is really a gigantic system. And you can see at the bottom I have written 483 nodes, dedicated nodes, and it runs for 90 minutes to complete this 21 member 10 days forecast, and then additional few minutes, around 75 minutes is required for all the products to generate and post processing. So in summary, 165 minutes, so little over. So it was told that operationally around 2.5 hours. So every day it is 2.5 hours. This whole model end to end, with all the forecast products being generated on the forecast products being uploaded, it takes around 165 minutes. It is fully automated. We have done no manual intervention right from the initial condition generation and perturbations until the end of uploading to the website. End to end, it takes around 165 minutes in the Cray computer, which is now located operationally. We run it in Mihi HPCSS NCMWF in Noida. Can we go to the next? Yeah, so this is a very brief, what are the components of this model. So there are basically, two major components. One is convection. So one good thing is this model uses a scale-aware shallow and deep convection. So being a scale, but even though it is a scale-aware, it has no scope to use this scale-aware convection, because it is a Gaussian linear projection. So right from equator to the pole, more or less the resolution remains 12 kilometers. Okay, so it has no scope presently to scale. But if we would have used a zooming grid, which becomes higher at the equator, then this scale-aware scheme, what it does, when your resolution goes below 10 kilometer, below 5 kilometer, it switches off the subgrid scale parameterization, and everything gets computed by explicit convection. But presently it is not done in the GFS, because everywhere it is 12. And there is a microphysics we use, there is a gravity wave and PPL and radiations. These are all, but we have now modified some of these microphysics and convection, which has not yet been operationalized, but we have offline tested, and we have seen that things are improving the model skill in extreme. Can you go to the next? Yeah, so these are all, when this 12-kilometer model got installed and started implemented in operation, then is whole suits of applications started in India, something like what the name of the rhyme suggests. So we started a probabilistic thunderstorm forecast. There is a even forest fire. This department also is using now our 12-kilometer forecast for 10 days to find out the hotspot of the forest. Then the district and block level forecast for agricultural application by IMD, cyclogenesis and track intensity, even hydrological modeling. I will come to that. And even solar and wind, non-conventional energy sector, they are also using this 12-kilometer forecast. And also we have a experiment on fog for Delhi, in national capital. So for that experiment also they are using this 12-kilometer GFS and also GEFS, to downscale to the airport location and so on. So these are a whole suites of applications. They were actually waiting for this model to happen. The moment it happened, they all started blooming with this probabilistic forecast. Okay, can we go to the next? Okay, so now I will briefly tell about few case studies which I selected. Yeah, so this is, I just selected because they are all, these systems, they have all partly affected the BIMSTEC countries or the South Asian countries. One is Pabuk, one is the Burevi cyclone and Bulbul and the super cyclone Amphan. Not all, but few of them. Okay, can we go to the next? Yeah, so this is, this is the super cyclone Amphan, and you can see when the cycle, this is a GEFS MSLP plot. The blue shading is the spread, and you can see it is from 15th May initial condition, and you can see it even when the system was just formed in the it appeared in the form of a depression over well-marked low and depression. The model captures that, and it from that time onward it shows that it's going to hit to the West Bengal coast and crossing over to the Bangladesh region. Okay, can you go to the next one? Yeah, and this is what is our probabilistic forecast, and this threshold of this rainfall, this was decided by IMD. So as per IMD's operational criteria, this 65.5 millimeter per day is considered to be the heavy rain. This is 11.5 centimeter is considered to be very heavy, and if it is more than 19.5, it is extremely heavy. And these are the different percentage of probability: 0 to 25%, 25 to 50, 50 to 75, and more than 75. So this is given to the forecaster, and if a forecaster gets this probability almost like 1 week in advance, it makes the disaster managers and the forecaster to make a good plan of the whole, the warning and all other associated issues. Can you go to the next? Yeah, so here you can see this super cyclone Amphan did show a kind of a rapid intensification, and some of the members you can see that they were trying to show this rapid intensification, if not all. So now here is the advantage. So I can actually compute the probability of to what percentage and probability this model is showing a rapid intensification and so on, even if all the members doesn't show the rapid intensification. Okay, but of course you can we can notice very well the model has shown a rapid weakening, but in reality this is IMD. This has not gone so rapid weakening was not observed, but model showed a rapid weakening. I'll come to this later. Can you go to the next? Yeah, now here you see this is the advantage of having an ensemble system. This blue line here, this is this is called cone of uncertainty or strike probability and so on. This the inner color is actually the it shows the 50 to 90% chance that the storm is going to pass over this region, and you can see this blue line, the blue line, actually it represents the track by the deterministic model. So the deterministic, the single model realization, it was showing that model the storm may go towards Odisha and Jharkhand, Bihar, but if I would have had only this model, then my forecast would have gone wrong. But you see, this black one is the MD and the red one is the ensemble mean, and you see because we have an ensemble, we can conclude no, this deterministic is not correct, because majority of the members, they are showing the model is going, the storm is going towards West Bengal and subsequently towards the Bangladesh. So this is one advantage. This is seen even, see, this is individual, all each 21 member has been plotted here, the tracks, and you can see here also, you can see very few are showing a tendency towards Odisha and Jharkhand, but majority of them is showing towards. So this gives the confidence. So even if the model has an uncertainty, we can overcome the uncertainty by using judiciously the ensemble forecast system. Okay, can you go to the next? Yeah, so this is another product, this is very useful, where we produce the EPS gram. This is also, ECMW have also produced that, and you can see in EPS gram we produce the relative humidity, the wind, and the pressure, and also the rainfall at 75th percentile and the median. This also gives the forecaster, and this is produced 10 days or 5 days or 7 days in advance. So this becomes additional tool to a forecaster to come to a conclusion that how much, now we are talking of the impact based forecast. So this gives an idea that how much impact in terms of sea level or in MSLP, or in terms of wind and rainfall is going to occur at a particular place, which is going to be hit by the cyclone. Can you go to the next slide? Yeah, so this is Burevi, which crossed very near to Sri Lanka and southern tip of India. Normally, this is not the time we normally expect the cyclone, 30th November and end of November and early December. But now it is happening, and you can see the Burevi cyclone. That also, 30th November, and this you can see is the initial condition of 27 November, and with sufficient lead time, this model also, forecasted well. Can you go to the next? Yeah, so this is the forecast probability for Burevi cyclone. Yeah, you can see that heavy rainfall probability is predicted here with the 27 November initial condition. Next. Yeah, so this is another one. This is Bulbul. This is also in 6 to 11 November. This is the post-monsoon cyclone. And this also, this is also was forecasted very well, by tracks and intensity, and of course, and also the genesis. Go to the next. Yeah, so this is again the probability. So the probability of based on a 21 goes hand in hand and gives a very very unique this thing for the forecaster to conclude about the impact of the cyclone. Can you go to the next? Yeah, so this is the strike probability of Bulbul, and you can really see that we cannot really the differentiate between the observed and the ensemble track. It is so accurate, accurately it has been predicted, and also here it is the MSLP and the wind, maximum sustained wind. That is one of the metric for cyclone intensity. Okay, can you go to the next? Yeah, so this is one very benchmark event we all know. This is 2018 and 19 August. It is one in a century, or rarest of the rare event happened in Kerala, and this is from Central Water Commission figure. Recently, we have heard something similar in Germany. Anyway, can you go to the next? Yeah. So we have recently published this paper. I can share this. It is online. I mean, now it is published in Weather and Forecasting, August 2021 issue, and we have given a very holistic approach, and we have compared. I will show that 3 modeling system in UM based, NEPS, GFS, and also ECMWF IFS, and we have shown that what we can do, where lies the strength of the ensemble forecasting system. Can I go to the next? Yeah, this is just just to give you an idea what has happened in terms of percentage departure by all the districts of Kerala on August 2018. It is just 6 to 19th August. You see 300% departure for 2018. Next. And this is, you see, 2019, almost similar. It is 200%, 300% of departure. Okay, can I go to the next? Yeah, and you see, this is the actually, this is the actual standard deviation, departure. And this is the climatological standard deviation. So when the climatological standard deviation is just 1 millimeter or 2 millimeter and some 3 millimeter, the actual standard deviation was 64, 40 to 50. It is, I mean, we can't think of. So that's why I gave the title more than 30 sigma. It is rare of the rare event, and really no model can capture this 50 sigma, 50 standard deviation. It is just not possible. Our science doesn't permit us to generate a variability which is 50 times, than the climatology. Okay. Anyway, so go to the next. Yeah. So what we did that we took the the threshold as climatology plus 1 standard deviation, climatology plus 2 standard deviation, and climatology plus 3 standard deviation. This is the blue curve, which is actually the observed. We all know in 2018 there were 2 peaks when the event happened, and you can see with 1 standard deviation, and this is GEFS and this is NEPS. So it is showing a probability of very high probability of 80% of this thing to happen, climatology plus 1 standard deviation, even 6 days in advance, and here you can see it is showing it is at least 5 days in advance. When we go to the 3 SD, GFS is not showing, but NEPS is showing, a probability even 4 or 5 days in advance. Can you go to the next? Yeah, and this is IFS ensemble system, and you can see for 1 standard deviation and 2 standard deviation of these two very well, it is capturing the probability of 70 to 80% with 4 or 5 days in advance. So what does it mean? It means that even if the model cannot capture that 50 sigma, that is not possible. But with respect to models climatology, if 2 standard deviation also is considered to be an extreme, okay, and this extreme can be predicted with respect to 4 or 5 days lead, and that is very much meaningful. So this is one of the best way of extracting information. Similar analysis was done by Peter Webster for Pakistan flood. So he also demonstrated that this type of extreme can be predicted at least a week advance. So that is what we have demonstrated here. In addition, we have also added some other analysis. Can I go to the next? Yeah. So this is another very, very important applications which has been started. Now it is operational. So this is the for using this GFS and GEFS for river basin, for hydrological forecast and so on. Can you go to the next? Yeah, so you can all I mean PPT are there with you. You can visit this site and you can see that how meaningfully this GEFS forecast based on its own hindcast is being bias corrected. And you can see there one sample here. This is over Mahanadi basin, over flood monitoring office of Bhubaneswar, and you can see this is the observation, and this was the raw forecast, okay, where it was substantially underestimated, but then it is forecast is bias corrected, and you can see that the things have been improved, and now it has actually extended up to day 5. If you go to this website, you can see, and also in IMD. Okay, go to the next. Yeah, can I go next slide? Yeah. So this is what IIT Gandhinagar, Dr. Vimal Mishra's group, in collaboration with IITM and IMD, they are using. This is 19th July, 2 days back initial condition and 5 days forecast. This is for Narmada basin. Okay, these shape files are provided by IMD, and it also shows the extreme at 90th percentile. It is very, very useful. This type of application can be very easily be made using this model data, which is every day generated for any river basins across Southeast Asian region for the benefit of the people. Okay, can you go to the next? Yeah, so this is again, I just showed one example. When the monsoon trough goes to the foothills, then suddenly the central India rainfall goes down, and the rainfall starts building up in northeast in the this region and surrounding countries as well. Now, can you go to the next? So what we do based on GEFS, next slide. Yeah, so based on GEFS, we produce block level rainfall probability. This is also very useful for the forecasters. And you see these are all probability for so more than 75%, and these are the rainfall categories. Okay, 11.5 centimeter and 19.5, where you can see all it is showing very high rainfall probability for these districts and blocks of the Northeast, because the model is showing a shift of trough to the foothills. Okay, so this product also is very useful. Okay, go to the next. Yeah, this is another very useful applications where we produce the probability for maximum temperature. So as per IMD, when the temperature goes above 40 degree or above, it persists for 2-3 days, then which is considered to be heat wave, and it is very frequent nowadays due to climate change and so on. So this GEFS provides a very strong tool to generate this Tmax probability, okay, at different threshold, 40 degrees Celsius or 42 or even 44 degrees Celsius, to see extreme heat wave conditions. Okay, can you go next? Yeah, so this is day 3 forecast. I mean, just wanted to see that how is the probability come. So it really, I mean, the ensemble forecast gives you the much needed lead time for tackling all the multi-hazard system, which is not possible by single model, approach. Okay, can you go to the next? Yeah, so this is another, applications where thunderstorm. Okay, and this is just an example. Go to the next. Okay, skip it. Next. Next slide. Yeah. So this in this slide we have just shown that different component of the thunderstorms, like this is the hail, this is the wind gust, and this is the some index of the supercell, and you can see that this is the cloud top temperature, and this is actually I mean where thunderstorm happened. So this GEFS, although I mean we are still improving it, it has not been, I mean we cannot say that forecast skill for thunderstorm using GEFS is very high, but we are still trying to improve it. But it is giving it provides a forecaster or those who run WRF or high resolution model. This provides them a possible region of hotspots where thunderstorm is the probability is going to be very high in the coming 5 days. This is used for 5 days. Okay, go to the next. Yeah, this is just a a snapshot of how one particular day this rainfall by 21 members they look like by our GEFS, and how from this we derive the rainfall probability. This is for a case of Mumbai. Okay, can you go next? Yeah, so this is the last year. Like this year also we have, every year we have this Mumbai rainfall, very heavy rainfall, and this GEFS EPS gram really becomes very useful for providing additional information for Mumbai Municipal Corporation as well as Mumbai RMC, where we get this heavy rainfall from the ensemble, okay, and sufficient at least 5 days in advance. Can you go to the next? Yeah, so this is also a probability from the large scale perspective. It provides, it is 11.5, or here you see 65.5. So here it is clearly visible that there is, and if this, persists for several subsequent initial conditions, okay, 0 UTC, 12 UTC, subsequent 0 UTC. If you continuously get this type of probability for extreme rain, then the forecaster has to take it as a signal, not as a noise. Okay, okay, go to the next. Yeah, this is again another event of 5th August, and you can see up to day 3, it is forecasted very well. Next. Yeah, you see, this is what I wanted to show. See, for 5th August last year forecast, you can see here all the members, all the 21 members, they are showing, they are matching with this IMD observation. And this is day 1, this is day 1, day 2, day 3. So even day 3, of course, value is to some extent less, but so it means that most the ensemble are coinciding, they are agreeing for this. So this gives a better, higher confidence and higher accuracy in the coherency of the ensemble forecast. Okay, go to the next. Yeah, so this is the same thing based on as we did for Kerala event. Here also we see if we do that climatology plus 2 standard deviation, it gives us a leverage of 5 days, which is really useful for the disaster managers and the forecaster. Okay, so next. Yeah, this is also another new product we have done based on hindcast of GFS. It is a percentile, okay, for rain and wind. And you can see for the 5th and 6th August, it is 5 days ahead. This forecast initial condition you can see. So 5 days in advance, we can see that these regions are going to be 95th percentile, okay, extreme expected in wind and rainfall. And this, if we see it on 5th day ahead and 4th day ahead, then forecasters become dead sure that a very strong, heavy rainfall, extreme rainfall event is going to happen over this region. Okay, next. Yeah, so now the question is, this is for policymaker. If someone asks that what did you gain by running this high resolution model? So here is an example. You see this black line, black solid line is the day 5 forecast, okay? And the blue dash line is the day 3 forecast using the Pearson model, what is P574, and they both are coinciding. Okay, this is some skill, Pearson skill score. So what does it means that the skill that we were getting up to day 3, using the lower resolution model, we are getting that skill is extended to day 5. So we have gained 2 days, by using this higher resolution forecast. That is what is coming here. Can you go to the next? Yeah, but there is one, everything is not so rosy. You can see here, this is the special analysis for ensemble, where I have plotted the spread. This is the spread and this is the RMSE, and you can see the spread is lesser than RMSE for all, 18, 2019 and 2020. What does it mean? Go to the next. Yeah, this is for cyclone also. Spread is lesser than RMSE. Yeah, go to the next. Yeah, so this is a slide I borrowed from ECMWF, and you can see this is called when the spread sigma is lesser than RMSE, it is called under-dispersive, but or other way it is called the overconfident forecast. Okay, so you can ask that why it is happening. In ECMWF, they have also their forecast also once upon a time it was under-dispersive, and under-dispersive means uncertainty is low, but it is overconfident forecast. So this is also not required. We need to improve it. And how we can improve, I can come to afterwards. Okay, so go to the next. Yeah, so this is also Brier score. Brier score is not so bad. Lower is the Brier score, higher is the skill. So for higher rainfall, we have a lower Brier score. That is good. Okay, go to the next. Yeah, this is also a very useful product. Skills. So if my model, this red line goes out of this cone, it means my model loses the skill. So what we can see here, you see for 65.5, which is very heavy rainfall category, even up to 0.70% or 80% probability, it is still within the cone. So it means up to 70-80% probability for 65.5 millimeter or 6.5 centimeter per day rain. This model forecast is basically useful. That's what is coming from this skill score computation. Okay, go to the next. Yeah, and this is a rock curve, relative operating characteristic. So it means that heat and false alarm. So a perfect forecast, false alarm should be 0. Everything should be, so it should be a vertical line. But we don't get that. There has to be, always a false alarm. So it becomes a triangle, fine. But how thick is the triangle shows how good is the model. So you see when we go to the 65.5, triangle area becomes smaller. It means the false alarm has increased. So that our target is, to improve this triangle look like this, or what is. So that's a challenge. That's what. But still, it is not, it is not useless. I mean, that's what is the point. So at heavy rainfall, the ensemble is still producing a meaningful forecast. Okay, next. Yeah, so this is one challenge, that variation of rainfall, shifting of the rainfall area. That is one of the very, very important bias that forecasters are always complaining, and we are working on that. Okay, the next. Can you go to the next? Yeah, no, okay, skip it. Maybe I can skip it. Time is less. Yeah, so now I think this is the last slide. Where do we go from here? So I will just repeat a few lines from Tim Palmer's white paper on Vision 2030, and he said, "It is my strong belief that we need to develop our NWP system considerably so that by 2030 they become reliable predictors of genuinely extreme events of 15 sigma." So he actually took this from this thing, and at least in the range where substantial proactive action can be planned and executed, say at least 7 to 10 days ahead of time. So he is basically talking about a system which is definitely ensemble, which will be probabilistic with stochastic physics, and it must give a forecaster, disaster managers, and users and stakeholders a lead time of 7 to 10 days. Okay, and it should also capture the extremes, what he has defined as 15 sigma. Now, what is our plan? Our plan is like this. We are planning to make this high resolution GFS to increase its resolution from 12 to 6 kilometers. Okay, and presently we are running it with 64. We are planning it to run it at 128 particle levels. What does it happen using 128 particle levels? I will show in a minute. And we are going to use a TCO framework, which is like called cubic octahedral framework, which is presently all ECMWF suits of model are being used in TCO framework. We are also going to introduce stochastic physics perturbation tendency. This is what I was telling. Why the model is under dispersive? One of the reason is that we are using stochastic total tendency perturbation, STTP, which was actually done early, used by NCEP. But this job will be done very soon, and we are also going to use more stochastic framework, and for handling this this shifting of the rainfall and this underestimation of the rainfall, we are going to use AIML downscaling rigorously. We have already started this work. Also we will finish very soon. And so we feel that to build a high resolution ensemble for improved extreme forecast with 7 days, this is achievable by this approach. But one more thing, last but not least, is that we will make our GFS as a coupled system, because unless we present what we are doing, we are using near real-time SST and we are persisting. That's what one of the caveats in our forecasting system. We are going to use a coupled GFS system that also would be possibly ready by end of this year. Can you go to the next? Yeah, this is just to see one example. When we run this GFS at 128 particle levels for same Kerala event of August 29, you see this is the observation of IMD GPM gridded data, and this is how the rain, and here you see 64 level. You can clearly make out how well the model has predicted the rainfall, heavy rainfall over over the landmass. So this is a clear example. Okay, go the next. Yeah, so this is the TCO concept. You can see that the equator, you can see the resolution goes very high, it becomes higher. Where in the tropic, in the polar region, the resolution remains little coarser. So this is the thing we are going to use. This is called cubic octahedral grid. Can you go to the next? Yeah, this you see I have written this TCO 765 is what is equivalent to our T1534. If we go to if we make it TCO 2300, then we come here. If we so gradually we can come to this green line, which becomes almost like 4 kilometers in the equator. So these are the suit of scale. Depending on our HPC, we will decide the truncation, wave number. And as of now, it is for sure we are going to TCO use. The model is already set up, and only where we truncate, that will be decided by our computing facility. Yeah. To the next slide, please. Yeah. So this is the last slide. So I should say the takeaway is the GFS ensemble forecasts are found to provide reasonably good scale of various weather phenomena that you have seen, heavy rainfall, thunderstorm, and with a longer lead. That is very, very important. GFS forecast also found to be skillful for heat wave, and also for the transition of monsoon from break, active to break and so on. Bias corrected GFS quantitative forecast for river basin is found to be extremely useful. Okay, and GFS based rainfall probability for blocks for IMD, blocks using this EPS drum and other metrics are highly found to be useful. There is a need to introduce SPPT that I have just now said that will actually help to reduce the gap of spread and RMSE and improve the GFS skill. And for your information, I have given the websites, all the websites down below. The GFS data are now available at TG archive. So one can go log in into TG and they can get the near real time. And I don't know, I have no idea. I feel that if someone, and I don't know who can do that, whether RIMES or MOES, if there is a regional NWP South Asia forum, I don't know whether it exists. If such a community is built, then I think we should keep in contact, in touch with each other, exchange our ideas, and most importantly, exchange our data. This huge data is getting generated for the benefit of not only for India, but for all the countries in the region. I think this is the last slide. Can I go to the next one? Yeah, so I thank everyone. I thank Srini in particular, all the members of SHF and RIMES for giving me the opportunity. Thank you.
So thank you very much, sir. Now, as you were introduced and get the information from Dr. Partha, next I would like to take you all to the Q&A session, which will be led by Dr. Srini and Dr. Ramesh. So over to you, sir.
Thank you very much, Pew, and also thanks to Partha for taking all the time to describe very in a stepwise fashion, particularly the importance of ensemble focus and how ensembles can help us, forecast things in a probabilistic way, and how it helps us to improve the lead time and the plans for improving and catching the heavy and disastrous hazardous events. So all this has actually, given a clear, direction for us to think, and for the working group on NWP to actually consolidate and see how we can progress as a region. And particularly his last slide, he left us with a thought that this can definitely be a regional approach, which is exactly what this forum is constituted for. So we are quite thankful to you, Dr. Partha, for this nice presentation. And I will ask Dr. Ramesh now to lead and coordinate the Q&A session, which is what we are now into. Thank you.
Thank you, Srini. Thank you, Partha, for a very elaborate and purposeful, thought-provoking presentation. And you have shown the promise of the existing GFS system, and then compared with the international best ensemble EPS system of ECMWF for a case study, which you have shown, and that shows at least in the probabilistic sense, severe weather from day 1 to day 2 at par this ensemble also is showing. And there are several ways of evaluating the model and parameters in terms of several dimensions. And it is up to the group here, once the data is available, how best we can make use of it. Particularly for the appreciation of David Roses, I just want to mention that the kind of effort presented before this audience is totally modeling side was totally physics tuning, fine tuning, and even the promising probably this stochastic physics, and that is tested already. It has to be put for operations. And then TCO spherical grid representation of the GFS, that framework is also tested. And when HPC upgradation takes place, so definitely TCO 1534 would be the immediate variant with which operations would be starting. Perhaps maybe end of next year, that can be a possibility in India. And till then, we have so much data, at least last 4 years of GFS data is available for the reason. And then the promise of severe weather developing is definitely brought out from the EPS diagrams. He has shown Bombay, he has shown Kolkata, he has shown some of the hill stations, some of Nepal and other Bangladesh locations he has shown. And this kind of EPS probabilities at different locations will show the probability of severe weather developing in a time scale of 5 days or 6 days, definitely. And then the high resolution WRF models, which are run at 3 kilometers, and very likely for hill states, several our working group members are running at already 3 kilometers now. With this kind of promise coming from the ensemble prediction, local models can be run at 1 kilometer, not exceeding 24 hours perhaps, to get the characteristics of severe weather 4 times a day with 0, 6 and 12, 18 GMT sort of thing can be taken. And the promise is there definitely, and in days to come and years to come, definitely the advanced physics suite and the resolution representation and its framework and the performance evaluation will continuously going on. This is what is the status of the operational ensemble prediction system in India. And we are separately carrying out ensemble prediction system separately. And briefly, I'll invite quick remarks from David Rogers first. Then I'll go to Professor Brahmanand Rao and then Professor
I
Bhaskar.
think, Ramesh, we have a few questions from the group. There is one from Nepal.
I've seen that.
Okay.
We'll have them. Yes. David Rogers, please.
Thank you very much, and thank you for an excellent presentation. I actually wanted to ask you, on your very last point about the sort of regional approach. As we know, creating ensemble systems is costly in terms of computing resources, and the fact that you can build a system which covers the entire South Asia region obviously suggests that we ought to focus as much of the computing resources in a single place, very similar to what you've already accomplished and what ECMWF has done for Europe, and it clearly it pays off. The question is really related to how do we convince the colleagues, the DGs of all of the countries in the region to think about pooling resources. Right now, we tend to focus in our investments as a part of World Bank teams, our investments tend to focus on creating computing resources that are really suboptimal when it comes to utilizing ensemble systems. So they focus on determinism, and as you've pointed out, that is not the approach we should be taking. The world is stochastic. We should focus on stochastic solutions. So the question is, how and what do we need to do to convince those DGs that may be somewhat skeptical of engaging in cooperation regionally? And then if we can convince them, what do we need to do then to convince those who are actually trying to help resource countries to improve their forecasting systems? Thank you.
So it's a very, challenging, challenging questions. I always discuss with Tim Palmer, and normally we are habituated from our childhood, we are habituated in a deterministic world. When I ask a cup of tea, if you give me a probability distribution of a cup of tea, that doesn't work. That's how we think deterministic way. We dream deterministic way. So our habit also develops. So it takes a huge time, to make this transition. It's a huge effort. But the point on which we can convince all the administrator or like managers or DGs or whoever it is, there is only one point. The disasters to be handled efficiently, you need longer lead time, and deterministic forecast cannot give any lead time. And we really do not know. Science, doesn't tell us that a deterministic forecast realizes and whether it is true or false. So in this dubiosity, if I put a lot of my money, if I put my society, it is actually I am putting them in risk. What I am doing, I am applying my model's uncertainty forcefully on my society. That should not happen. Society doesn't know the uncertainty of the model, but I am taking it and passing it on to the stakeholders. I should not do that consciously. If I believe in science, I should acknowledge the uncertainty of this forecast, and I should pass it on, intelligently, by which the most meaningful part of this forecast can be utilized. That can only be done with ensemble forecast. And as an example, you can cite an example of this huge effort taken by TIGI. And this TIGI effort is there since 2015 or even before that, right? And this forecast, now our model also is going there. And the best part is this forecast and this parameter, everything is now freely available. I mean, if anybody wants to use it, so this resource is being generated at one country, fine, that country also is leveraging the benefit out of it, but a huge portion of it is remaining underutilized. So there is no point in wasting the resource. I think this is high time. All the river basins forecast, everything should be initiated immediately, because disasters are happening, frequencies are increasing. So there is no point in believing in one WRF on one HCM and claiming that my model is good, your model is bad. We should come out with all these limitations and this thing, and we should really and then there is no harm if you have IFS, for example. If you have this IFS ensemble system, you can build a multimodal ensemble. That is even better. We have seen, multimodal ensemble in simplified. That reduces the error even better. Now in India, we have two systems, which is 21 plus 21, 42 ensembles. Now we are actually, but to do that multimodal ensemble, you need the handcast, you need the reforecast to decide which one is good and which one is bad and which instance, and accordingly you assign the weights. Then only it will be a meaningful multimodal ensemble. But one can do that. I mean, we should walk in that pathway. We should head toward that. We should adopt that. There is no point in ignoring this huge resource and making it unutilized. So this is my submission. Yeah.
Rogers, as a regional strategy, we have to build a roadmap of showing the promise of this ensemble product and its evolving promise with future planned upgradations in the frameworks, and then link it to the country level deterministic forecast, high resolution deterministic WRF type of thing. But those models of WRF high resolution ones have to be driven by a best assimilated data of the region. So unless the best assimilated data at that resolution is generated and pushed into the model, so that improvement of severe weather in 24 hours scale or 36 hours scale cannot be expected. So that's where the effort of assimilation of high resolution assimilation, pushing radar data and other things have to happen. So that's what we'll plan under our regional strategy approach for the region. And then whatever distributed computing resources are there, they can be made best use of for deterministic and multimodal ensemble output for probabilistic severe weather beyond 3 days to 5 days for the region. So perhaps some such thing we'll discuss more on that under our collective wisdom, and to build a strategy and make best use of the investments are already done and that are in the pipeline for the region. Okay, now I go to Partha. There is a question from our Nepal colleague. His question is, do you have some example of remarkable false alarm and misses from these model products?
Yeah, it is always there. I have not picked them up for today's this thing, but one can easily make out from that ROC curve that I showed that when you go to higher resolution, the area of the triangle becoming shrinking. It means the model's false alarm for that particular category of rainfall is increasing. Now, if he or she wants a very particular specific example, for example, recently in Mumbai, sometime back in month of early first week of July and so on, all the models were showing that there will be a very extreme event. Okay, and even Mumbai RMC issued the warning, but it turned out to be a false alarm. It happened very recently, so there sometimes, but it not so happen. We find this false alarm reduces substantially an ensemble. Okay, and one has to see subsequent ICs. What I always insist that one IC may give a indication of extreme, but 12 UTC IC and 0 UTC IC, if I see subsequent 3 IC and I see that the probability remains same, then it's a signal, not a noise. But if it is a signal, it will not persist in consecutive ICs. So that way one has to handle this false alarm issue.
Yes, Shanti Kundil, as you have asked, we have to see the consistency of severe weather prediction in successive initial conditions, which Partha has mentioned. So once we see that is happening in 0 GMT, 12 GMT, next day 0 GMT, then we are sure of. If it is going in one initial condition and is not maintained of the severity prediction, then we have to keep our fingers crossed. So these are some of the things operationally when we use, so we will understand the strengths and weaknesses of this framework, and then we can find out what is the best way of using this guidance and going for the prediction and then applications and response systems, etc. So with regard to apart from the modeling, the general forecasters, we have about 36 operational forecasters, distinguished people who have been working in 9 different countries in South Asia, right from Afghanistan to Myanmar and Bhutan, Nepal to Sri Lanka and Maldives in this group. So I request our distinguished academicians, so how to build the required knowledge base and the understanding, deep understanding of the dynamics, synoptics, and the thermodynamics of the region, and at the local level in particular, to make best use of these ensemble products and modeling products available, and how to build that knowledge and understanding, which will make the forecasters more wiser and skillful in understanding and capturing the signals coming from NWP models. First, I go to Professor Brahmananda Rao from Brazil to add his wisdom to this particular sequence of building knowledge and understanding, making them more wiser to make use of these numerical weather prediction products. Professor Brahmananda Rao, please.
Thank you very much, Dr. Ramesh. The talk by Dr. Partha is very, very interesting, and to my knowledge, it is almost up to date compared to any other countries in the world, including the advanced countries. But I have some specific suggestions. The following question to Partha. Suppose you invest a lot of money in running the model with very high resolution and same advantage, relatively simple, less expensive model with better physics, with a better understanding of the problem concerned. Please, can you respond to this, Dr. Partha?
So you are suggesting to use a simpler model, is it?
Simpler model with more understanding of the physics of the problem. For example, in the case of tropical cyclone, if you use a relatively less expensive and simpler model with more understanding, with better what we is not advisable?
Yeah, I will respond, sir. The point is like this, sir, that presently, the operational centers across the globe, and including India, they have an approach to use one model for all disaster systems. Okay, earlier we used to have a concept that I will run one model for tropical cyclone, another model for thunderstorm, another model for monsoon rain, and so on. Now the approach is seamlessness. So one model will be equipped with all the ingredients so that it can be applied for tropical cyclone as well as for heavy rain, for thunderstorm, and so on. Now, so that is why the models has become complicated. But as you are telling, that approach is still there, sir. What we do, we run a simple model. We have a GFS single column model, sir. That is called one-dimensional what known as single column model. That is very simple. It doesn't have so many ensemble members. It can be run even in my laptop here. Okay, that single column model we run with observed data. Okay, I can run with the sounding at say Visakhapatnam. Okay, and in that single column model, we do test all these physical inconsistency. For example, this cloud radiative forcing. If I find it is imbalanced in my three-dimensional model, I try to run this single column model. And these are all, I mean, I have not explained here. And what we do, sir, we try to apply all our scientific knowledge and scientific concept and all innovations in this model, try to test it in simple model. And when we find that, yes, this is working and this is resolving my case, then we test it in three-dimensional model, and then we run this GEFS very heavy, expensive model. That is the approach, and that is this hierarchy of model approach, sir. It is applied in everywhere, including ECMWF and also in NSEP. This is the present way of handling this issue.
Yeah, thank you. But I am suggesting a very interesting approach, which about 35 years ago, Dr. Adrian Gill suggested. What he suggested was a KUM approach, three-pronged approach, where K is the knowledge, means completely observational studies, U is the understanding, and M is the modeling. What he suggests was, if you do not have complete understanding, at least some understanding, if not complete, of the system we are using, just using a brute force of increasing resolution. I see in the literature, even 1 kilometer, you can even reduce to half a kilometer. So instead of using this brute force with a lot of money spending on it, if you did not completely answer to my question earlier. What I was the same model, not the one-dimensional simple model, the same model we are using. If you have better physics understanding, it will definitely improve the forecast. So you see, for example, recently, the Western Europe floods, some of the most advanced countries in the world with a very, very high resources could not cope up with the flooding that has happened, and even several deaths occurred. So we are going to have scenarios like this in future. And as I read, to my knowledge, the understanding of the tropical cyclones, particularly the post-monsoon cyclone in the Bay of Bengal and also in the Arabian Sea. There is a recent study by H. Murakami and Wang Professor Bin Wang, of all the tropical cyclone bases in the world, the lowest correlation with the present understanding is for the North Indian Ocean, compared to almost 0.8, 0.9 correlation to North Atlantic tropical cyclone. The correlation for our North Indian Ocean is almost 0.2 only. That means you are trying to forecast systems which you do not understand physically. So, by brute force of a model which are developed for predicting systems elsewhere, because to my knowledge, all the models developed by, say, countries like United States or Britain or the Western Europe, we borrow them here and without improving or the what you call understanding the knowledge for our system, we just use those models and simply increase 1 kilometer, half a kilometer. Instead of that, suppose you invest more money for our poor countries, particularly these regions of Southeast Asia and all. If we invest more on understanding, and that is, I think, relatively less expensive also. What we really need probably is some expert guidance to improve the physics, the knowledge, the understanding that you part, probably that's a better approach, I suggest. But in any case, your talk is excellent. Your talk is really excellent. Very, very interesting.
Sir, what you told is
Thank
correct.
you.
That's how we are spending a lot of money in India for process studies, based on which the special data sets are generated, high resolution data sets are generated, following a thunderstorm or following a boundary layer process, and for convection test beds are created. So to get the more process studies related data, specialized data set, multi-scale observing systems are put for the campaign, and then the understanding improves, and all that data is used. That's how the Partha is getting ready with stochastic physics, and tested it also, which has shown more improvement compared to the existing suite of physics. So that effort is on, sir. Definitely. And at the same time, he is first checking the improvement prospects from the one-dimensional model with all the new physics formulations changed. See, even at par with the international developments, thunderstorm physics and lightning physics was incorporated into our models very recently, and at par with other developed countries, and at par with the development of that science explicitly in prediction. So it is a continuous process. For a process study, it's major groups and many groups have to come together and observe different phenomena using different equipment. So that process is also on. So simultaneously, both the efforts are there. The Ministry of Earth Sciences and other academic institutions are part of that effort. Even with UK groups and European groups, some of the studies are planned and executed, including the aircraft-based measurements are going on. So all those results we will have to discuss and see how they are improving our promise of improving the skill over the region. But nonetheless, your emphasis on improving the knowledge and understanding is very important. Now I call upon Professor Bhaskar Rao for his piece of wisdom. Sir, your mic is muted, sir.
Thank you, Dr. Ramesh. The talk by Dr. Mukhopadhyay is excellent. We know his expertise. We know his expertise in the physical parameterizations, understanding, and also the development of models. I'm very happy that he has given us his status of the global forecasting system models and their applicability or their usefulness, taking the Indian scenario into considerations. His focus was on the heavy precipitation events, the heat waves, lightning, etc. As an academician, I felt always that the ensemble prediction is good to make it the users to understand the uncertainties in the predictions that are being given, whereas the model development and the physics development, their usefulness in the predictions have to come from deterministic prediction experiments. That has been probably the way things have gone so far. I really do not know. I wish Dr. Mukhopadhyay has emphasized if there has been improvement in the limit to predictability of some of these extreme weather events by taking from, for example, from the regional model predictions to the global model predictions and to the ensemble predictions. I wish he has spent some time. Probably he should have known from his experience how things have worked. That's number one. Number two, if the model developments should be made, as you said, on the India has made many observation data sets to make the physical parameterization schemes, but to a large extent, I agree with Dr. V.B. Rao that we borrow some of these models, use them like a black box by most of the groups. But we certainly know, at least from the academic point of view, that many of these physics parameterization schemes that are being used as they are being provided by the model system, they may not have 100% applicability all over the globe for all of the weather systems that we experience over the globe. Even over the India, our experience has been that. So things have, there should be a global focus, there should be a regional focus, and the regional people should spend time to improve the system as it suits for the region. That's, at least that has to be important. And because this is a South Asia group that is being focused on, and things should be discussed, because the problems for each of these countries could be very much different from what we are discussing for India. And I do not know what is the general science standard of these forecasters everywhere. And there should be a uniform understanding of either the GEFS or GFS, what is becoming available, because many of these things, though they are available, many of them are using, many of them do not know probably the limitations of the data or the forecast data that is being available to the system. So I wish there should be a coordinated effort to make, you see, there could be a model, but sometimes we may need different kinds of changes or model system changes to suit to the regional needs, regional forecast needs. And I think Dr. Mukhopadhyay did not touch upon the regional limited area forecast models that WRF everybody uses, but that finds a lot of application in the prediction of extreme weather events over India. He has shown one event, Kerala rainfall, using the GEFS system, but I'm surprised to see that the limited to predictability is only up to 24 hours. And even that, only the accumulated rainfall or the total rainfall has been predicted quite reasonably well. But some of these extreme weather events may need much important information, like in the case of the extreme precipitation events, the rate of rainfall is a lot of rainfall could happen in few hours. And what is the predictability of that? So that probably amounts to and what we have experienced apart from Kerala, Chennai a few years ago. And even today we see that 2 days back, Hyderabad. And this is probably a very important application. I think the IMD, IITM should bring a balance between the development, deterministic prediction, ensemble prediction, and the improvements in the weather prediction of some of these extreme weather events. Dr. Mukhopadhyay probably can comment, Dr. Ramesh can comment.
Thank you, sir, for the guidance. That's what Partha also mentioned at his last few couple of slides, that the beyond 65 mm per day, so that improvement in the quantification probability, quantified prediction of rainfall quantum, so more research needs to be done. That's why he has proposed even the coupled model of GFS in days to come, once the computing power is appropriately enhanced. So definitely these things are taken into consideration. And we have 3 questions from the audience. We have to take them one by one. So now
Dr.
I take.
Ramesh, can I just one sentence to
both
please. Dr. Rao and Dr. Professor Bhaskar Rao. So, sir, actually the point is, because in this webinar I was told to speak mainly on the operational forecast and its application, etc. So I focused on what is the present state of the art. But just to clarify,
please,
in IITM, we mostly do for improvement. We mostly do for the improvement to improve this model, especially keeping the regional variations in mind. For example, I will tell you only 2 examples here. You are mentioning about taking something from regional model and transferring it to global model. We have exactly done that. Papers are already published in that. What we did, we have seen that in GFS presently, a very simple microphysics is used, which does not represent all the different spectrum of cloud, which we experience in India in different seasons. So, but we have seen in WRF in single what is that what is WSM6,
Yes, WSM6, yes.
Yeah, so WSM6 schemes works very fairly well in WRF. We have seen from our earlier experience. So we have used that scheme in GFS, that is one, and CFS. Now, as Professor Rao was telling, do we use it blindly? No, we don't use it blindly. What we use it.
No, not you. Not you. Any of the groups, not
I. No, I'm not talking about you.
Okay. I
maybe other reason.
No, I'll tell you, sir, what we did. No, there are tendencies, sir. So what we did, sir, in Indian, IITM conducted one KIPEX experiment. Data is now freely available. In that experiment, sir, for 2-3 years, the flight data was collected. So what we did, we used that flight data to modify this WSM6. We have done that. And then that modified WSM6, we put it in CFS. There is a paper in BAMS by Surya Chandra Rao. If you see there is a Taylor diagram. In that Taylor diagram, there is a 100-kilometer model, which is very coarse resolution, very simple model. There we have used this modified microphysics and improved convection. We have seen the scale of the model is as good as the high resolution 38-kilometer, CFS T380. So we have already demonstrated that. And we are going to do that in GFS also. Second, sir, Indian radar, it's a huge resource. The radar is the best source to give you the spectrum of cloud and its time and its frequency and its lifetime, everything. But this information has not been utilized so far in our parameterization. So we have used, sir, we have now used that all, some 10 radar, east, west, north, south, and we just that may be another webinar in some other day. And what we have done is that we developed the probability distribution function and the transition probability for different seasons of cloud, and then use that information in a stochastic model of cloud in CFS and GFS, and then run the GFS. So those are all, sir. I mean, if I give that webinar, that will be another, long webinar. I have not touched upon those, but we are continuously.
Very nice, Partha.
Appreciate. Thank you. Thank you very much.
Similar question is asked by our participant. Cloud formation processes are not same in Indian subcontinent in different season. Different cloud physics need to be used for different season. This is a question. So that's what. Please elaborate on this also.
Yeah. Answer is very simple, Dr. Ramesh. Answer is that, see, clouds. What does a cloud scheme do? It is based to produce a rain. It produce coalition and coalitions. Okay, there are different processes. Now, the question is, say in monsoon we find a domination of low cloud. In pre-monsoon or post-monsoon cyclone, there are formation of different clouds. The point is, these are all stochastic process in every grid. So that's what I just now told to Dr. Professor Bhaskar Rao, that we have developed that scheme. We have not yet operationalized it. We have developed that scheme for the whole season from January to December for all the grid. What should be that cloud possibility, probability, and its transition from one to other. Now this information, if it goes to the model, then scheme based on that can actually handle whatever be the season and whatever be the cloud.
Wonderful, Partha. On this, if you have any write-up or manuscript, you can share with us. We will share with our colleague Kamarul Hassan, who has raised it.
I will share.
Thank you.
The stochastic concept is very interesting. I think you would come up with much more improvements of that to go into replacing physics representation in the model.
True, sir. True, sir. That is the hope with which PFS still can go up.
Very much appreciated. I know. I think.
Yeah, Partha, we have two more questions quickly. One, our colleague from Maldives, Rashid, has asked, is the data set from GEFS T1534 accessible and available for regional NMHs for further post-processing for specific product generation at local level? Yes, that is there. But another point is, can these GEFS dataset be used to run WRF model at higher resolution along with additional data assimilation?
Yes, absolutely. Yes, absolutely. Yes. See, for example, our fog experiment, what is being conducted in Delhi, that exactly they have done the same thing. They have assimilated the local Delhi data. They have used GEFS for initial and boundary condition, and they have now generated a probabilistic fog, formation.
Yes.
Exactly what he or she is telling, it is already demonstrated.
So wonderful, Dr. Rashid. This opportunity exists, and this has been tried out for fog prediction over North India in winter.
Paper is already published.
So that paper also please share with us, Partha. Shini?
I think, Ramesh, that is exactly what Rashid has raised is a very pertinent question. And Partha has given a very good clarification. And I think this will add up to our regional strategy when we start working.
100%.
Thank you. So I think we have one more question. From Ananda.
Yes, Ananda. That's what I'm asking. It is related to future development, Partha. Anand from IMD is asking, what about the coupling of GEFS with ocean model? What is the plan of coupled DA, data assimilation, to provide consistent ocean atmospheric IC to the model?
So that's a good question. So we are very much after that. So we are going to couple this GFS. We will make it coupled by end of this year. We will make it a coupled GFS, and then we will go beyond 10 days. That is one. And coupled data assimilation also, with Professor Yugina Kalne under monsoon mission, that coupled data assimilation also is getting shape. I think they have made already progress, and that also, in the coming years, that coupled data assimilation will be a reality, and then we will really get a modeling system which is high resolution, coupled along with coupled DA. So that they are all
under monsoon mission. That effort is on.
Yes. Very much.
Very quick remarks from David Rogers first, then hand it over to Dr. Srinivasan for his remarks. Rogers, please.
Thank you very much, and thank you for a very interesting debate. I think as we see the challenges in NWP remain, and but also it's an extremely exciting prospect for the near future that we have made such progress. And I think while we continue to debate stochastic processes and determinism, I think we are on the right track in terms of ultimately improving the ability to predict the hazards for the population of our societies. Thank you very much for a brilliant presentation. I enjoyed it very much, and look forward to the working group actually taking up on your challenges. Thank you.
So under this webinar series, we try to present the current status and the future development prospects for your appreciation and appreciation of our working group members of the region. Thank you very much, and I now call upon Dr. Srinivasan to.
Thank you. Thank you. Thank you. Thank you, Dr. Ramesh. Thank you, David. And thank you, Partha, Professor Bhaskar Rao, and also Brahmananda Rao from Brazil. Thanks very much for all your comments, suggestions, and interesting debate, like David said. And this will, like Partha said, the very fact that we have overshot the planned time shows that there is a lot more discussion which has to happen to guide this working group's process and formulation of a strategy, which will be quite a challenging task. I am particularly thankful to all the participants who have taken time to join us and also post some very thought-provoking questions, and which we will take up during the functions of the working group. So with that, I think we can treat this as an excellent beginning for more such sessions to happen, interesting sessions which will guide the focus for the region and also address many regional issues like physical processes and maybe how to put together ensembles to get the best out of them for the region, and also use them to force local models like Rashid has raised. So thanks a lot, and I think I'll turn it over to Hitesh now. He has a small poll about this session, very briefly. And with that, I will thank all of you and also wish you a nice day and week ahead. Thank you very much. Over to you, Hitesh.
Yeah, thank you, sir. I think we just put the poll online. You could actually see a pop-up in your screen, and you can just answer those. I think there are very few questions only. 5, it will take a few seconds.
Just because we are learning on how to do these things and what best would help all of you and keep it interesting and also short and brief as much as possible. So that's the intent of this few questions as a whole. So thank you very much again, and best wishes.
Bye for now.
Okay, bye.
Thanks for
bye. Thank you.
Thanks,
Thank you.
Partha.
Thank you. Thank you. Thank you. Thank you.
Great, Partha. Enjoyed.
Yeah, thank you. Thank you. Thank you so much.
Yeah, your talk is wonderful, Dr. Partha.
Thank
wonderful.
You, sir.
Very interesting, very important.
Thank you, sir.
Thank you.
Thank you so much.
Bye, David. Thank you, Pew. Thanks to the team.
Bye-bye.
Hey, everyone.
Bye.
Goodbye.
Bye, bye.
Thanks, Pew.
Great, Anshul, Hitesh, Kaushalya, Bencho. Wonderful.
You, thank you, everybody. Thanks to all the participants.
Thank you, sir.
Questionnaire finished?
No, it's still going on.
Going
we have 50% so far. I think a few more.
Okay, let's work on it. Let's work on it.
Yeah.
Good. Relax now for the day. A lot of effort by Hitesh and Anshul, Kaushalya, Bencho for this event. Great. Went very well. Extremely well. Bye.
Yes.